Assalamu alaikum. I'm Arfa Tahir, working as Deputy Director in RAM's Road Asset Management System, Communication and Works Department. It is a pleasure to talk about something that plays a vital role in the safety and sustainability of our infrastructure, the Bridge Management System or BMS. Think of BMS as the brain behind smart bridge maintenance. It combines engineering evaluations, detailed inspection data, and cost projections all in one place. This system empowers us to prioritize repairs, plan proactively, and make decisions that are not only technically sound but also financially responsible. So today we will explore how BMS transforms scattered data into actionable insights, helping us protect and extend the life of our bridge assets. Here is what we will be covering today: a complete walkthrough of how the bridge management system works and why it matters. We will begin by understanding what BMS is and why it plays such a crucial role in infrastructure management. Then we will look at the vision behind it, structured through the PDCA cycle, which guides our strategy and continuous improvement. Next, we will dive into the types of inspections we conduct, along with the procedures that ensure accuracy and consistency. We will also walk through the review and approval process, a critical step in ensuring that no detail is overlooked. Together, these elements form the backbone of how we manage bridges, from identifying early signs of wear to carrying out major repairs in a timely and efficient way. So what exactly is the Bridge Management System or BMS? Simply, BMS is a smart decision-making tool that helps us get the most value out of our resources, whether it is for inspections, routine maintenance, major rehabilitation, or even full replacements. Its core purpose is to ensure our bridges stay safe and structurally sound over time. And how does it do that? By giving agencies like our access to powerful tools that track bridge conditions and forecast costs using solid engineering data. It shifts us from reactive maintenance to a more strategic and proactive approach, which saves time, money, and most importantly, reduces risks. Good, fair, poor, swear. These are the four main categories RAMS uses to rate the condition of bridges. As you can see, this classification helps us assess the structural integrity of the bridges we manage. The condition ratings we use are determined through detailed structure assessments. These assessments often involve using damage indices, which give us a quantifiable measure of the bridge's conditions, and visual indicators, which allow us to assess the bridge at a surface level. Let's break down each category in more detail. Good. This indicates that the bridge is in excellent condition and requires minimal, if any, maintenance. Fair. Our rating suggests that bridge is functional but may need some repairs or monitoring to prevent future deterioration. Poor. When a bridge is rated as poor, it requires significant repairs or attention to maintain safety. Swear. Swear conditions indicate major structural issues that may require immediate attention or even replacement of certain components. Each of these ratings provide us with crucial information about the current state of the bridge, which directly informs our maintenance planning. Why is this important? These ratings help us prioritize our maintenance efforts. Bridges rated as good need less attention, allowing us to focus resources on those that are fair or in poor to swear condition. With these ratings, we can plan repairs and replacements more effectively, allocating our budget where it's needed most. RAMS is a comprehensive system that provides crucial insights into the state of our infrastructure. It helps us address several key aspects of asset management. Asset current condition. RAMS allows us to assess the current state of each asset, providing a snapshot of its condition. Critical asset identification. It helps us identify which assets are critical and need the most immediate attention. Project performance. We can track how well our projects are performing over time, ensuring that goals are met and standards are maintained. Best investment strategies. With the data collected, RAMS enables us to make informed decisions about where to allocate resources most effectively, ensuring that we get the best value for our investments. Now, let's look at this graph, which represents the relationship between the age of the bridge and its condition severity. As you can see, the graph illustrates how the severity of the bridge increases with age. As bridges get older, they naturally face more wear and tear, which raises the likelihood of them falling into poor or severe categories. What's important here is the impact on repair costs. The graph clearly shows that as a bridge condition worsens, the cost of repairs also increases. Bridges in severe condition require significantly higher investments in repairs and maintenance. This highlights the importance of proactive maintenance before the condition deteriorates to the point where repairs become more costly. This data drives the need for timely intervention. By identifying critical assets and understanding the relationship between age, condition, and repair costs, we can prioritize maintenance efforts more effectively. It allows us to focus on preventive measures for bridges that are aging but not yet in severe condition, saving costs in a long run. Since 2023, we have had the valuable support of JICA, who has been helping us align our asset management system with international standards. This collaboration has been crucial in enhancing the way we manage and maintain our infrastructure, ensuring we follow global best practices. Through this partnership, we have been able to integrate several advanced techniques into our system. Some of the key methods we have adopted as a part of this initiative include life cycle costing. This method helps us understand the full cost of an asset over its entire lifespan, from construction and maintenance to eventual replacement. Life cycle costing gives us a clearer picture of the long-term financial commitment associated with each asset. Risk-based planning. By analyzing the risks associated with different assets, we can prioritize maintenance and repairs based on criticality. This approach helps us allocate resources more effectively, ensuring the most at-risk assets are addressed first. Data standardization. Standardizing our data ensures consistency, accuracy, and ease of integration across systems. It also helps in benchmarking our performance against international standards and allows for better decision making. Aligning with these international asset management standards ensures that we are not only improving the reliability and efficiency of our infrastructure, but also making smarter data-driven decisions. We are better positioned to plan, execute, and manage our assets in a way that is both cost-effective and sustainable. Our ultimate goal is to build a system that is fully supported by, number one, governance, means strong leadership and policies that guide every aspect of asset management. Number two, train personnel, skilled staff who are equipped with the knowledge and expertise to carry out their tasks effectively. Number three, structured processes, well-defined and consistent processes that ensure we manage assets in a systematic way. Number four, integrated technology, advanced tools and systems that help us gather, analyze, and manage data efficiently. Quality data means accurate, reliable, and timely data that forms the foundation for decision making. Together, these elements enable us to deliver cost-effective and sustainable service to both current and future users. To achieve our goals, we follow a structured approach known as plan, do, check, act cycle. Let's break it down. Plan. The first step involves setting clear maintenance objectives and creating inspection schedules. This allows us to anticipate needs and plan resources effectively. Do. This is where the action happens. We perform inspections and carry out necessary repairs according to schedules we have set. Check. After inspections and repairs, we evaluate our performance. Are we meeting our objectives? We also update our data to ensure it reflects the current state of the assets. Act. Based on the insights gained from the check phase, we take corrective actions. This could involve refining processes, addressing issues, or improving strategies for the future. This cyclic approach ensures continuous improvement, helping us stay on track and adjust as needed to meet our long-term goals. The PDCA cycle is vital because it encourages a regular evaluation and adaptation by continuously assessing and improving our processes. We ensure that our asset management practices are always evolving to meet changing needs, ensuring efficiency, cost effectiveness, and sustainability. One key innovation we have introduced is app-based inspections. These inspections ensure data consistency by allowing inspectors to collect information in real time using mobile technology. This eliminates errors that may arise from manual entry and ensures that all the data we gather is accurate and up to date. To enhance the reliability of our asset management system, we have integrated inventory data with inspection data. This integration allows us to have a comprehensive view of each asset, combining its physical attributes with the results of its inspections. This is not only ensure we have more reliable data, but also streamlines the maintenance planning process, making it easier to track and manage assets effectively. Another critical component is the use of dashboards and mapping. These tools allow for visual tracking of assets condition across the network. With dashboards, we can quickly view key performance indicators and identify any areas of concern. Mapping provides spatial context, helping us visualize where each asset is located and its current condition relative to others. Finally, we utilize damage scoring to help us prioritize repairs. Each asset's condition is scored based on the severity of its damage. This helps us make data-driven decisions about which assets need attention first, ensuring that we focus resources on the most critical repairs and reduce the risk of asset failure. Field formation performs, according to the SOPs, routine inspections on a monthly basis. These regular inspections ensure that we stay on top of the condition of our assets and can identify potential issues before they become major problems. Consistent monitoring helps us maintain the safety and functionality of our infrastructure. In addition to field formations, monthly inspections, RAMS conducts periodic inspections at set intervals. These inspections allow us to assess the broader health of our assets, ensuring that we meet the required standards and follow best practices for asset management. Together, these inspections provide a comprehensive view of condition of our assets over time. After each inspection, field formation updates the dashboard with data on repairs and any new construction activities. This update process ensures that all stakeholders have access to the most current information, allowing for timely decision-making and effective planning of resources. To further enhance our reporting capabilities, we are introducing editable forms for both financial and physical reporting. These forms will streamline data entry and ensure that all necessary information is captured accurately. This will not only improve the speed of reporting, but also make it easier to track both the financial and physical status of our assets in real time. So, the sound bridges will be inspected every 5 years and the repaired bridges will be inspected every 2 years. Ensures timely detection of deterioration from inspection to diagnosis, planning, repair, and re-evaluation. This will make a continuous loop based on engineering inputs and asset performance. Bridge maintenance flow. Data is the foundation of everything we do in asset management. Without reliable data, our decisions are based on assumptions instead of evidence. Why data matters? It supports forecasting future deterioration, prioritizing critical repairs, budgeting accurately, and reporting to stakeholders. Good data enables us to shift from reactive to strategic planning. The life cycle of data use. Plan inspections over multiple years using asset condition trends, implement and validate the results of maintenance activities, design repairs that match the specific condition of the asset, execute and analyze post-repair data to measure performance and guide future planning. In short, data is what transforms a maintenance program into a strategic asset management system. It connects planning, action, and evaluation in a continuous loop. Our system uses a composite damage scoring method to objectively prioritize bridge repair. What this score includes? The score is calculated by combining three key factors: defect severity, how serious the damage is; structural importance, how critical the damage element is to the bridge overall integrity; and location of the damage, whether the defect is in a high impact or a high risk area. Why it matters? By combining these factors, we generate single score that represents the urgency and impact of the issue. The score is then used in prioritization models to help us plan which bridges need repair first, ensuring that we allocate resources efficiently and address the most critical risks. The BMS algorithm includes score, which is sum of inspection score and inventory score. Inspection score is calculated with parameters like damage type, damage extent, damage rank, and severity. Damage score is calculated with weights of damage types, damage ranks, and importance of factors. The important factors are defined in above tables. These factors are incorporated in the algorithm, and a score is generated on which the prioritization of the bridges is based. What is bridge inspection? Bridge inspection is a systematic process used to assess the condition, safety, and functionality of a bridge. It involves the thorough examination of all parts of a bridge, including its superstructure, the portion above the bearings, substructure, foundations, abutments, and piers, and the goal is to identify any signs of deterioration, damage, or wear that could affect the bridge's structural integrity and safety. Inspectors are responsible for evaluating various components like beams, girders, columns, bearings, and expansion joints for issues such as cracks, corrosion, deformations, and spalling, etc. For example, the breaking or flaking of the concrete. So there are different types of inspections. First one is the initial inspection. An initial inspection conducted when a new route is constructed or an existing route is reconstructed on a large scale in order to grasp the initial condition of the completed structure that provide basic data to future maintenance. Number two is the routine inspection. This inspection is conducted on a daily basis to find anything unusual about structures with the aims of keeping traffic safe and smooth and preventing damage to the third parties. Number three is the periodic inspection. This inspection is conducted on a structure in close proximity at certain intervals based on a long-term inspection plan with the aims of finding damage or deterioration that may cause functional decline at an early stage. Special inspection. This inspection is conducted to meet the necessity of maintenance of a structure as it occurs without specifying the objective of inspection used to design for the repair. Emergency inspection, it is conducted after a natural disaster or an incident to act proactively whether it can affect the bridge or not. The methodology for different types of inspection. Periodic bridge inspection is relied on visual hand touch inspection, which requires an experienced and thoroughly trained bridge inspector to ensure following. All critical, non-critical bridge damage should be recorded. Type of damage should be identified rightly. The severity of the bridge should be documented properly. The extent of damage should be noted for budgetary estimation. Detailed bridge inspection is relied on visual hand touch inspection as well as non-destructive testing and dating by bridge engineer to determine the type, extent, and severity of damage. Methodology for different types of inspection. Our bridge inspections are categorized into 3 levels, each using different tools based on the depth of assessment required. Routine inspection. Routine inspections are conducted more frequently and use basic tools to check for visible signs of deterioration. For example, it uses nodes, binoculars for documentation and binoculars to hard to reach areas without physical access. Periodic inspections are more thorough and conducted at set intervals every 2 or 5 years. Advanced tools used are pole cameras, binoculars and drones, under bridge inspection vehicle and hammers, etc. Detailed inspection. When structural integrity is in doubt, we perform a detailed inspection. Special tools used are the non-destructive equipment like ultrasonic testers or rebound hammers. These tools allow us to assess internal conditions without causing any damage to the structure. This tiered approach ensures that each bridge gets the right level of attention based on its condition and risk profile, while also improving safety and cost efficiency. Now, what is the method of taking pictures of the bridge? So, to maintain consistency and clarity in our inspection records, each inspector follows a standardized photo protocol. Overview photo. The inspector takes 5 overview pictures to capture the general layout and condition of the bridge from different angles. These help establish context for the specific findings. Span photos. For each span, 3 to 5 are taken to document its condition and structure in detail. This ensures that every part of the bridge is visually recorded. Defect documentation. For each defect, the inspector captures 3 specific views. Foreview shows the defect in the context of the entire structure. Middle view focuses on the defect area with surrounding visibles. Near view provides a close-up for precise evaluation and measurement. These photos are critical for accurate assessment, diagnosis, and long-term tracking of structural issues. Our inspection process is carefully structured into 3 key phases to ensure thoroughness and data accuracy. Pre-inspection. Before going into field, inspectors should review the bridge inventory to understand the asset's background and past issues. Plan traffic safety measures, especially if inspections require working near live traffic. This includes coordination, detours, signage, and flagging. During inspection means on-site, inspectors photographs visible defects for documentation and comparison. Record measurements such as crack width and corrosion extent. Rate the severity of each defect using standardized scoring methods. This ensures consistent and objective condition evaluation. Post-inspection. Post-inspection, after completing the fieldwork, inspectors upload the collected data into the central system or the dashboard. Verify entries to ensure accuracy and completeness. Complete final checklist which help confirm that all required steps were followed and no observations were missed. This structured workflow from preparation to reporting ensures that our inspections are both efficient and reliable, forming the foundation of effective bridge asset management. Inspecting bridges often involves working in hazardous conditions, so safety is a top priority. Our inspectors are specifically trained to handle high-risk environments, whether it's working at heights near moving traffic or over water. Key safety include personal protection equipment, PPP, helmets, gloves, high visibility clothing, and other gear to protect against injury. Fall protection systems, harnesses, and safety lines when working at elevation. Traffic control, proper signage, and coordination with authorities. These precautions are critical not only for the safety of our inspectors but also for maintaining uninterrupted inspection quality. Second evaluation of the bridge inspection. Our inspection data goes through a three-stage validation process to ensure both accuracy and reliability. First check, it's the field inspector. The process begins with the field inspector who conducts the initial assessment on site. This provides first-hand data on the bridge condition. Second check, consultant or the RAMS team. The inspection findings are then reviewed by the consultant or the RAMS team. They verify the data, cross-check for consistency, and apply technical judgment. Final check, secondary evaluation team. Lastly, the second evaluation team performs a final review. Their role is to ensure the assessment meets quality standards and is free from bias or error. This multi-level checking system strengthens our decision-making by ensuring that no critical issues are overlooked and that the data we rely on is thoroughly vetted. Bridge management cycle and maintenance cycle. In infrastructure management, we operate on two essential levels, management and maintenance. Management is strategic. It follows the PDCA cycle, guiding long-term planning, resource allocation, performance evaluation, and continuous improvement. Maintenance, on the other hand, is operational. It focuses on the day-to-day action, specifically the cycle of inspect, repair, ensuring that assets remain functional and safe on both ground. Both levels are equally important and interdependent. Strategic management sets the direction, defines priorities, and ensures accountability. Operational maintenance turns those strategies into action, preserving asset condition and extending service life. Together, they form a complete full cycle infrastructure management system where strategy informs actions and real world performance data feeds back into better planning. So this is the end of my presentations. Thank you.